Hi, good morning, or afternoon, or evening. This video is going to be a recap of week 11. So that is the week of Halloween, October, I believe, 26th to the 30th. And it's going to include the lesson for the previous 2 days, November 2nd and November 3rd. So to get us started, I'm going to kind of go out of order. I'm just going to show you what we have here on the Zoom, or on Schoology. As you may notice, Schoology has been reorganized, at least as far as my classes are concerned. So the first link is our Zoom code, Zoom link. Second one is our office hours, only available on Fridays. The third is to the YouTube channel, which if you're watching this video, you probably found this here. The fourth one is the chemistry feedback survey. This was done during week 10 or so, but I've changed it up to make it anonymous again. So if you have grievances you want to air or whatever, compliments to give, click on that, send me some feedback. And now let's go to Unit 1. Everything we've done in the past half of the semester has been put into this Unit 1 folder, including our test that we took last week. Let's go ahead and click this open. So if I click this open, our first link is the link to the evidence notebook we've been working on for the last 10 or so weeks, including all the assignments, all the notes, the study guides, the reviews, it's all in there. Followed by our textbook, which we kind of used, kind of didn't. Our notebook kind of took its place. And then all the week's worth of materials, followed by the assessment at the end, as well as our notes, which I'm still checking, by the way. Let's click on that. So last week we took our assessments. As you can see, they're still enabled. So if you haven't done it yet, you can still do this. If you haven't done it yet, I'm just marked it as a 0. You have 7 attempts to do this. I know most of us are going to take 1 or 2, and that's fine. 7 attempts is for those extreme cases who are like, all right, let's try our very, very best here. I grade by the highest score, so take it easy. Just so you know, if you're not satisfied with your score, you could do it again. It's always an option. So we did that on we did that on Tuesday/Wednesday last week, the week of Halloween. Get that out of here. After finishing the test, we moved on to Unit 2. And the first thing we did, as you can see, there's the week 11 materials here, we took our pretest. The pretest lets me gauge where you're at as far as the concepts we're going to cover here are concerned. So if you haven't done it yet, please do so. It lets me set a baseline for your improvement. We also had a secret Halloween lesson. I'll get to that in a minute. Go ahead and close that off. Close that off. Following the Unit 2 folder, we're going to have our textbook for Unit 2, as well as the new notebook. I took your feedback into consideration when I decided to make a new notebook. Originally, I wanted to just have it all in one giant document. Still doable, but I realized that's Google Docs probably not the best method for that. So I already have this clicked open, so I'm just going to go ahead and scroll all the way up here. Unit 2, heat and energy. Like I said, pretest is our first thing. But before any of that happened, before I let you guys do the pretest, I made sure we all made a copy of this document. That is absolutely vital. I want to make sure you guys start off on the right foot here. So when you make your copy, rename it to, Fall 2020 Chem Notebook Unit 2, and then make sure you include your name, right? Replace the your name here with your name. After you do that, make sure you share it to my email, sami.azad@lausd.net. Make sure that's happened. And after you do that, you should be all caught up as far as Unit 2 is concerned. Now, after that was done, that's when I let people take the pretest. And to give you more incentive to take that, I'm telling you right off the bat that our final for this unit is 1. We're going to retake that pretest. Nothing changed. It's just for a grade now. And then the other half of our final will be making 2 models of the Earth. Now, I don't mean styrofoam, cardboard paper, paint. I don't mean that kind of model. I mean a model that will let us predict several aspects of the Earth. We'll get into that when we get into that. Just for now, be aware that your pretest is essentially your final. Okay, so I had a secret Halloween lesson, and we're talking about light and energy, which kind of fits with the theme of energy, but it's more of a second semester kind of thing. And so there are several videos I had you guys watch here about the colors that are made when we ignite a metal ion. But like I said, this is more of a second semester thing. So if you weren't there, you weren't there. And it was really for Halloween, especially this last video here, as you can see. So if you weren't there, you weren't there. I'm not going to reference this in our pretests or any time throughout the rest of the unit. So it's there just for you guys to peruse. Now, today, and by the way, that was a recap for the entire last week. You had to have been there. For today, Monday and Tuesday of November 2nd and 3rd, we went over our notes on systems and thermal energy. So the first part of that is making sure our vocab is filled in for numbers 1 and 2. And so I get these definitions from the book, as well as, common sense. So thermodynamics, let's break that word down. Thermo and dynamics, right? Thermo. If you have a hot soup and you want to keep it warm, you put it in your thermos. If you want to measure the temperature of your apartment complex, you use your thermostat. If you want to measure the temperature of yourself, if you think you have a fever, you get a thermometer. So the word therm just means heat, right? So if you have thermodynamics, it's the dynamics of heat. How does heat move around? How does it transform and transfer from different types of energy? And so that's what this is. This is the relationship between heat and other forms of energy and the ways that energy can be transferred or transformed. So if we're talking about the movement of heat, an example of that can be found in hot air balloons, right? If you've ever seen a hot air balloon, it has like a little flame at the very bottom of the balloon, and that flame heats up the air. The hot air rises, cold air sinks, and that's thermodynamics. Next up, we have internal energy. Sometimes these words are very straightforward to understand. Internal energy, energy that is internal, energy that is inside of something. And so that's our definition. But instead of saying something, we're going to stick with more scientific terminology. And instead of saying something, we're going to call it a system. And so internal energy is energy inside of a system. So if I took the heat energy of a human body, I could say the internal energy of a human being is 37 degrees Celsius or 98.6 degrees Fahrenheit. That's one way to gauge internal energy. There are multiple ways to do this. So moving on, we're talking about heat and systems, right? Thermal energy and how it exists within several systems. So the first image I have here is water. How is it possible that water can exist in 3 states of matter in the same area? We have clouds, we have flowing water, we have solid ice. And what we decided on is that it's possible because temperature and heat energy are not uniformly distributed. It's not the same everywhere. They vary based on location and other factors that are around that area. But how is this important? How could it be important with regard to the Earth? Let's take a look at some images I had shown you guys. So I think I was looking at a geographical version of Earth. I like pulling this guy up because it's really bright. So if temperatures were evenly distributed, you would not see these patterns here. You wouldn't see a band of white at the top and bottom. You wouldn't see brown, green, more brown, then more green. That's not how it works. You would just see one color all throughout. Luckily for us, as human beings, that temperatures are not the same everywhere we go. And so instead, we just have one giant desert in the middle of the supercontinent there. Then we have some lower end deserts down there, and then rainforests and more forests. And so temperatures and how they differ, they let us predict weather patterns and climate changes. When I talk about climate changes, take a look at the Sahara Desert 10,000 years ago. 10,000 years ago, the Sahara was green. Here's one artist's rendition of it. There used to be inland seas within there. So we know that the climate changes, and then that changes local conditions, right? It used to rain a lot in the Sahara, but over time, the climates have changed when those temperatures change. There's a lot more that goes on to it, but the temperature and the thermal energy in that area is a big deal of that. So moving on, let's talk about hot air balloons. What type of system is a hot air balloon? Open, closed, isolated. This is something we refer to in assignment 1 when we start talking about different types of systems. So just to refresh your minds, an isolated system is a system where matter and energy do not flow out. In a closed system, matter does not flow, but energy does. Think of like, let's say like a window. Doesn't let any, like the glass doesn't let anything but heat enter. An open system lets matter and energy flow freely between them. And so I asked you guys this in a poll. Hot air balloons are able to be open systems. Matter, aka air, which is the stuff we breathe, and energy, which is heat, flow very freely throughout that hot air balloon. And so as in the image in your notes, you could go ahead and click that, press the word edit, and you could draw on it just as well as I did. Let's go ahead and zoom us in. Let's pick the scribble option. And so now we could scribble in our lines. Done. Okay, so let's save it and close it. And try to draw something similar to this, where you can see the air coming into the balloon and then out as it gets heated and cooled and then out of there. Okay, let's move on. The follow-up question to this is, what type of system was the Earth system? And again, very straightforward. Earth is an open system. We let matter in and out all the time. Asteroids, comets, hopefully no comets, spaceships, meteors, these things come in and out of Earth all the time. That's matter, and not just spaceships, but air, water vapor, all that stuff leaves the Earth very frequently. And energy in the form of sunlight hits Earth pretty much all the time. It's constant. Let me go ahead and mark these off with our color we picked, almond. I like to have these notes be very noticeable. All right, next up, also asked in the poll, do you think warming a cannonball in a fire has any effect on total energy? Yes, it has an effect. It's gained thermal energy. If we were to weigh it, if we were to weigh a warm cannonball, I'm fairly certain it would weigh more. So how would you describe the idea of pressure? I asked the students this in the form of a headache. How would you describe a headache? You feel like a buildup of pressure, a pulsing in the head, a force. And when I heard that, you gotta specify a force where? Behind the eyes, behind the ears, behind the back of the head. It's on a specific area. And so pressure is force in a specific area. And we're here with the last one now. Particles with more kinetic energy collide with surfaces with a weaker or greater force. This is asked in a poll, but this is kind of the secret behind chemistry. It's all stuff you're all very aware of and is somewhat intuitive, right? If you throw something with more force, it's going to hit something with more force. That lines up with what you've seen. And so the trick with chemistry is to change your perspective. So all these common examples that you face every day can be related. And so when we're talking about more kinetic energy, that's going to make more force. And if pressure is force in a specific area, and then if we have more force, our pressure is going to increase. And so we decided on that. Lastly, the pressure in a vacuum is 0 because there are no particles in a vacuum. Let's think about that. If particles create the force and the force creates the pressure, what happens if there are no particles? If there are no particles, there's no pressure, 0. And so if you took a balloon into space, the particles on the inside of the balloon would eventually burst the balloon, and then the balloon would come right back down to Earth. Same thing with your eyeballs and other parts of your body. If you go into space without a spacesuit, your eyeballs will pop out of your head. And that's where we let it off. Like I said, this is like a cut down version of what was talked about in class. In class, I had many more images and stories to share, but that's the gist of it. We only went to number 5. On Wednesday/Thursday, we'll be covering up number 6 and 7 and getting started on assignment number 7. To kind of hold off on you guys, to kind of just remind you one last time. On Friday, I'm not collecting anything. However, it is a great time to catch up on older work and update that older work for a better grade. Currently, I'm grading through assignment 6 and checking those notes for your last units. If you haven't done it yet, you still have some time. And that's about it. The 15-week grades are coming up real soon. Window opens up on Friday. Until then, I hope you guys enjoyed this video, and I will see you all later. Bye-bye.